In this video we're going to look at Pythagoras theorem, but in terms of differentials, and this allows us to derive a couple of nice little trig identities. So let's draw out a triangle like that, and it's a right angle triangle, and if we call this little distance up here our infinitesimal distance dy, and we call the distance along here an infinitesimal distance dx, then this length here will be an infinitesimal distance ds. So we can write down the Pythagoras theorem for this, and we can say that our ds squared is going to equal our dx squared plus dy squared. Now what we're going to do is we're going to divide throughout by dx squared first of all, and we'll see what we get. Okay, so let's divide both sides by dx squared. So we're going to be left with ds squared upon dx squared is going to equal, well, dx squared upon dx squared will just be 1, and this here will be dy squared upon our dx squared. Okay, so we'll just rewrite that as ds upon dx, and that's all squared, is equal 1 plus, and we'll just change the nomenclature of that, just make it a little bit simpler. That's going to be y derivative squared. Okay, now we'll take the square root of both sides, and we'll be left with our ds upon dx will equal, will be 1 plus y derivative squared, and I'll write it all to the power of a half. Okay, so we're just taking the square root of both sides. Now the thing to note here is that if we make that angle theta, then we can say that cos theta is going to be that dx upon ds. Okay, so we'll write that down there. We can say that cos of theta is going to equal the dx upon ds. But now we've already got above ds upon dx, so what we need to do is we can make cos theta equal this above by taking the reciprocal of what we have above. Okay, so we take the reciprocal of what we have above, we end up with our dx upon ds is equal to, well, 1 plus y derivative squared. Now instead of being to the power of a half, because we're taking the reciprocal, it'll be to the power of minus a half. Okay, so now we've got a nice little trig identity. So I'll write it out in this form here. So cos theta then is going to equal, well, with this thing up here, so we could write that as 1 upon the root of 1 plus y derivative all squared. Okay, so that's our first little identity, and you'll see that cropping up all the time in calculus of variations, and you'll see it cropping up now and again in maths, and it's a handy thing to keep note of, and it's a dead easy thing to derive as well if you forget it. Now we'll do the same thing. We'll do the same thing for sine theta. Okay, so we'll write down our Pythagoras. So ds squared is going to equal our dx squared plus our dy squared. Now what we'll do this time is we'll go and we'll divide throughout by dy squared. So we're going to be left with ds squared upon dy squared is going to equal dx squared upon dy squared plus 1. Okay, so we can then write that there as our ds squared upon dy squared equals, now if we can rewrite that as 1 plus, well, that's going to be 1 upon y derivative squared. Okay, so that's going to be 1 upon y derivative squared. So all we've done is we've just changed the nomenclature to y derivative. and it's going to be the reciprocal of it because it's dx upon dy as opposed to dy upon dx. Okay, so it means that we can then rewrite that, and we can take a common factor for both of those for this here. So we can then rewrite that as our ds squared upon our dy squared will equal, well, the common denominator would be y derivative squared, so that's the same as writing y derivative squared plus 1 upon y derivative squared. Okay, so now if we were to then take the square root of both sides, we'd be left with our ds upon dy would equal, well, the square root of the top line would just be, now I'll just write it in terms of the square root sign, square root y derivative squared plus 1, and if we take the square root of the bottom line, well, square root of the bottom line will just be the y derivative, the square term will disappear. Now we know that we can write our sine theta, so sine theta from our triangle up here, sine theta is going to be our dy upon ds. So we can write sine theta equals dy upon ds. Now we're almost there, but we've got it round the wrong way. We've got ds upon dy, so if we take the reciprocal of both of these sides, then what we're left with is our dy upon ds would equal y derivative upon the root of y derivative squared plus 1. So we can then write this sine theta is equal to y derivative all upon the root of y derivative squared plus 1. Okay, so that's a little trig identity number 2. Got a little bracket around that there. Now, what you could do yourself is, if you want, be an interesting little exercise, you could then go and say, well, what would be the tan theta? So tan theta would equal, well, tan theta is the same as saying sine theta upon cos of theta. So it's the sine of theta upon the cos of theta. So it's this thing here, equation number 2, divided by this thing here, equation number 1. Okay, so whenever you go through that and you divide those throughout, you're going to end up with the simple thing that tan theta will equal y derivative, which is right. You know, tan theta is just our dy by dx. Okay, so we already know that anyway. Okay, but that's just a little aside. So one other thing you can do, if you are interested, you could look and see like a simple trig identity like sine squared theta plus cos squared theta should equal 1. Okay, so then what you can do then is you can take this thing here and you can square it, and you can take this thing here and square it, and when you add it up you should equal 1. Okay, so I'm not going to do that there, I'll just leave that as an exercise, and you can do that yourself if you are interested. Okay, that's all for this little video. Thanks for listening, and I'll catch you on the next video. Goodbye.